So we're going to take a look at delegates and events here. Okay, here we go. All right, good deal. All right, so we got Unity here. What I want to do is I'm actually just going to create some cubes in our environment here. And the character is just there for unknown reasons, but we're going to go ahead and let's just create a few cubes here. And we'll kind of scatter them around. All right, so we got one there maybe, here. I'm just going to create kind of a handful of these guys. All right, and we'll be good here. All right, so we have a handful of cubes in our environment, and what I'll do is I'll move our camera over here. Let's do that. All right, here we go. So we have basically these cubes. Now let's imagine you were creating a program where when you hit the space key, you wanted to turn all of these cubes to red. The brute force fundamental way to do that is to locate all of the cubes, maybe store them in a collection, whether it was an array or a list, and then loop through that list and modify their material properties and tell each one to turn red. Now we're going to create that implementation because it's important that you can see how that's done, and we're going to identify the pitfalls with that implementation. And we see this across the board with people who are self-taught software developers who've never worked before. Where they fill their projects with get component all over the place. Real software engineers, when you're working professionally, you need to be able to build maintainable, scalable, and flexible software, which uses delegates and events. And I'm going to show you how you can create production-ready code to create the exact same effect. So we're going to call this, let's call this, turn red. And we're going to attach it to our player, just the hazmat guy. Let's go ahead and just drop it on there. And Unity, it's not letting me do that. It's compiling. Okay, let's drag that on. All right, great. All right, so the first thing, in order for our hazmat character to turn those cubes red, how do we go about doing that? Right? We need to define those cubes. The program doesn't know about the cubes that you're trying to turn red. We can dynamically locate them by the name, or if we wanted to, Unity has a tag system, right? So we could tag them as cubes, essentially, like create a new tag and call it cube. And we can basically locate all cubes in the scene and populate an array that way, right? Or I could create a variable of type game object array, and I could manually drag them in. There's no wrong way to do that here. The important thing is that regardless of how you do it, our turn red script, which is on our player, has no idea the cubes exist. So whether we populate an array dynamically or we establish it, we have to define it. Your job as a software engineer is to define those traits. Let's see here. So we're going to create let's do that. Let's create an array here. So an array of game objects for the cubes. So private game object. And we use the array brackets. And then here we'll call them cubes. Now if I serialize this, I could then add those cubes in the inspector. And then basically I manually drag and drop them, which is problematic because if I drag and drop them, if we look at the hazmat here, I now have an array of cubes and I can go ahead and start plopping them in, right? However, let's say that I were to, let's mass add all these cubes here. What happens now if I created a second cube out of this one? This is now no longer in the array, so it's not going to be supported, right? So I have to remember to constantly drag it in, and now it's in the array. A better way to do it is to actually dynamically populate it at the start of the game, to where I can basically populate that array by saying, hey, cubes equals, and we're going to do gameObject.find, and I can find all of the objects with a tag. So here, find game objects plural with tag, and the tag is cube. If we save this and test it out, we can see here that if I set the size of this to 0 at start And it's annoying to have to start your game every time, so I'll show you what we can do instead. But you can see at start, it's going to turn red. So instead of that, there is something called a context menu. And I can do it for void start, I can do it for any method. But essentially what we're gonna do is we're gonna add an attribute, and I think it's called context menu. And context menu name, and we're gonna call this get cubes. And by putting that above any method, it allows me to actually use the hamburger menu here instead of the start button. And you'll see here the hamburger menu at the bottom says get cubes, and it will execute that code. So here I found all the cubes in our game, and now I want to turn them red. Okay, so we actually don't need to be in play mode to do any of the things we're gonna do. Now the process of actually turning them red. So here I can basically say, okay, cool. We need to loop through them, right? So we can create a for each loop here or a for loop. And here we'll say in cubes. And then we're basically gonna access each cube. We're gonna get the mesh renderer component. Once you have the mesh renderer, we can access the material. And then we can set the color equal to color.red. All right, so this is a brute force implementation of how you would actually see this in many projects across the board. And what I want to look at here is the pitfalls of this and how it should be done professionally. Now, if we test it out here, just going to go to the context menu and get cubes. They all turn red. And I'm getting an error, instantiating material due to calling rendered material during edit mode. Okay, it doesn't like me calling functions like that in the edit mode, but it's okay. It's more so just warnings. All right, so here we go. So we basically have it to where we can turn everything to red when we execute that function. It just occurred to me that I won't be able to test that again because we're hard coding it. So instead of red, let's turn them into random colors. And we can actually do that really easily through the random class. There is something called random.colorHSV. And that should assign it a random color every time I run the context menu. And each one should have its own random color. There we go. All right, cool. All right, so the problem with this, like we discussed, is what happens if I do this? I create another cube, and it's gonna be right here, and I run this context menu, get cubes. You'll see here that it's ignored. Unless I change it to a tag of cube, then if I run get cubes, it will hopefully, well, whoops, I've accidentally modified the hazmat. Hold on. Set that back to our player and grab that cube and set that tag to our cube. Okay, here we go. If we run it again, and let me see here, it's angry. Hold on, our hazmat is still cube, that needs to be player. And let me resize this. It's already populated. Okay, there we go. All right, so it looks like it still isn't grabbing this one, and that's because that tag is set to player still. If we change that to cube and try it again. Weird, I'm not sure what is breaking on that cube. It is very angry. It thinks it's like hazmat. Oh, hold on guys, I'm sorry. This is locked. Okay, cube 7 is untagged. It needs to be cube, and hazmat needs to be tagged as player. There we go. All right, we'll save our scene, and let's go back to our hazmat context menu, get cubes. There we go. Okay, so now it's supported, right? The problem with this was that I had to create the new cube, and then I had to tag it as cube in order for it to be supported here, or drag it manually in the inspector. Long story short, it's a mundane process that a designer has to be aware of. Versus, what happens if we had, let's say I would take these objects and I duplicate it, and then let's take them again and duplicate it, and again and duplicate it. Now currently, this, because they are all tagged already as cubes, there shouldn't be any issues here. However, what if I were to, let's say we forgot to tag them, right? And now we run this again, and we'll see here that when I select our hazmat, only those who are in our array, which is 11 out of like the 20 cubes, are changing. It's a process to get all of them to change. And so delegates and events can help us solve this problem. Delegates and events allow us to create what's called an observer pattern, where the cubes, when we create a new cube, could actually register to be notified, hey, I want to listen for when I should change colors, and I'll assign my own color. Versus right now, this turn red script, it's responsible for one, knowing about all of the cubes, which is a bad design choice, and then two, it's looping through all of the cubes to change their color, which is also a bad design choice, because it means I have to know those cubes exist. What if I had 10,000 cubes in our game? Do I need to know about all 10,000 cubes? Not a chance. A great place where you'll see in video games delegates and events used, like in a feature that's really visual, is an AI system. If you've ever played a video game where you're damaging AI and they call for backup, that call for backup is most likely implemented using a delegate and event dispatch system, almost like an observer pattern where those AI enemies communicate with each other through the use of events. So for example, that an AI is taking damage, it can actually send off a request, hey, I need help, and AI that are in the vicinity can receive that message and act accordingly. I don't have to know who the AI is, I just have to send out a message. You can think of it just like a police dispatcher. When someone on the radio is calling, all police officers can hear it, and they can selectively choose what to do with that information. The dispatcher doesn't actually know all the officers that are on the radio. They're just sending out that broadcast, and whoever wants to receive the information can receive the information. We can do something very similar here with delegates and events, and I want to show you that. So we're going to change this up a bit. This turn red script is solely responsible for telling the program to update. Let's say basically, hey, go ahead and turn red. So I'm going to remove the variable because we don't need them. We don't need to know about all the cubes in the scene. I don't need to loop through anything. And instead, here, we'll change the name of this too, just in case it doesn't like being called start. Let's call this, here, change cubes. All right, so all we're going to do here is just send out a broadcast that that I want you to change color, right? And you can choose to ignore that message, or you can choose to abide by that message, essentially. So the way this is going to work is I'm going to send out a broadcast. All right. Now, in order for us to do that, we need to define what that message is going to look like. We're going to define the message that potentially a cube is going to subscribe to. And the way we're going to do that is using the delegate keyword. So we use delegate here, and delegate is basically like a function pointer. So here we're going to say public delegate void, and let's call this update color. And we can even pass in a random color if we wanted to, right? We could actually say, hey, color random. We'll call it random color. All right, this is the declaration of a delegate. This delegate needs to match now a method syntax in order for us to register to it. But the important thing here is that there's two steps. We declare our delegate, which is to update colors. And then the other thing here is we're going to create an actual event for this. And I think I'm going to need a namespace here, but we'll see. And I think it's actually, I can't remember if it's event action or event handler that I want. There's a rule for how you can raise these events. And I don't fully recall it off the top of my head here, but essentially what we're going to do is we're going to say, okay, cool, I got public event update color, which is the function name here. And we're going to call this on update color. And I think, hold on, let me see what we're supposed to use for event here. There's something I'm missing here. I can't remember if it's static event option. Something lets me make it to where you can only raise this in this class. We'll see. For now, I'm going to keep it static. The reason why I'm going to make it static is so that it's accessible from anywhere else in our program. I can literally just say turn red dot on update color, for example. If it wasn't static, I'd have to register to it, but I believe this might be what I'm looking for. That lets it so that only this class can raise the event. But here, this is what a delegate event looks like. Essentially, I'm creating the option for cubes. I'm creating the option for cubes to register to having their color update. So to save this, I'm just going to go into our cube class here. We're going to create a new script. We're going to go over cubes, and let's go ahead and drag this onto all of them. So if we look at all of this, cube. Okay. So the way this works is this cube class is going to register to listen for, hey, Hazmat wants us to turn red or some random color. I will do that. And the way we do that is through the awake method. We're going to register and deregister these events. So for example, I can actually access from the cube class, I can say, okay, turn red dot on update color. And if we were to do a plus equal sign here and tab, it will actually give us the function that it's going to call. I'm essentially adding this function to a call registry in our other class. You can see here that this matches our delegate. Turn red, parameter color, random color, right? Or void, private void, we'll call this just, this can be named anything. We're just gonna call it update color. And then here, this needs to be update color. There we go. All right, so update color, so it's void update color, and then we pass in a parameter of color. This matches our delegate here. You can see here that we have in our delegate, it's a function declaration here, void update color, color random color. That tells us the signature that our event is going to use. This is actually our event listener, where we can actually now register to that. So our cube here is basically going to say, hey, I want information about updating the color. And then here we have something called, there's a method called private void on disable. And basically what's really important here is if these cubes ever get destroyed or turned off, or when we stop playing in the editor, you'll create a memory leak if you don't turn this off. So we want to make sure that we are unsubscribing events when, just like we do in Start to subscribe them. We want to make sure that we are unsubscribing as well. Otherwise you will create a memory leak. And we just say, hey, minus equal update color. Okay, cool. So now we have the actual code here. This cube exists in our scene, let's say 20 different times, right? I think there's like 20 something cubes in here. There's 20 cubes in here and they all have a cube script. Each individual cube is going to be responsible for updating their color based on the instructions sent out from the dispatcher. They should all be the same color even though it's a random color. So here we're actually going to just modify ourselves. We're going to say, we can basically just access our own mesh renderer and update our color. And we'll talk about why this is so beneficial in a second. But essentially I can just say get component, mesh renderer. I'm going to grab my material and set my color equal to the random color. Yeah, and Tamika, this is Visual Studio that I'm using with Unity 2021. Okay, so check this out. Turn red, and it's going to send out a broadcast all these cubes. Now this broadcast isn't going to work in the editor because nothing's actually executing right now, and I think I'll get some weird effects if I do that. So what we're going to do instead is when I hit the space key, we're going to call this change cubes method, and we actually have to raise the event. The event is currently not doing anything. I'm going to change this. Here we go. We got update here. We're going to check for the space key. So when we hit the space key, I basically want to call change cubes. And in this method, I need to send out a broadcast, but I don't want to just blindly do that if nobody is subscribed. If nobody cares to hear what I have to say, then I'm not going to broadcast anything. So what we can do is we can just check if anyone is actually listening. So if on update color is not equal to null, is anyone actually listening and wants to be notified when I want you to change color, then we will do that. And we simply just raise the event on update color. We call the event. And if I open a parenthesis, it follows the delegate signature. So a random color, random.color HSV. All right, so if anyone is listening, meaning it's not null, there's people registered, which such as these cubes, right? All of them in void awake. Then when I hit the space key, we're gonna go ahead and broadcast out what color I want you to change to. Let's run this. I hit space, and you'll see here, they all will change colors every time. What's amazing about this system though, is I'm gonna take all of these cubes, and I'm gonna move them up, and I'm gonna duplicate it and create a bunch more. And notice that our program is still going to work the exact same way, no matter how many cubes. And what's really amazing about this, and again, we can duplicate these all day long, and as long as they have that cube script, they are subscribing to our event. The reason why this is so powerful is my turn red class. This class has nothing to do with those cubes. It doesn't even know the cubes exist. It's not its job to know those cubes exist. The reason why this is so powerful is because I can actually take this generic class and I can put it into any project and I won't break anything. This cube is the only thing that is dependent on that turn red script. This turn red script though is generic. It doesn't rely on any other objects. And that allows me, it's really powerful because I can now take this, I could create a better SDK and I can actually put it in every single project I have. And now the option to have color changing across my projects is available for whoever wants to register to an event like that. So it's a huge performance saver. It cost us nothing to change these, by the way. When we are modifying the colors or anything like that, delegates and events, they're stored in memory from the start, and it costs you nothing to use it, versus every time we actually change the color in looping through things, you are creating garbage collection every frame. And so all of that needs to be cleaned up. This is a very performant way to do things. Great examples of this, where you see this done commonly, is tower defense games. How do we know that like all 10,000, for example, enemies or balloons made it to the end? They fire off an event that goes up in the air, and whoever wants to be notified of that event can be notified. Those cubes don't have to, or those balloons or enemies don't have to actually communicate with anything. There's a simple flag that goes up in the air, and there's a game manager who's listening for that event. And if it matches the enemy count that should be expected, then we start the next wave. And the whole purpose of this is that it allows us to do something called decoupling of our code. The only thing that's coupled here is the cube class. It relies on turn red, but this turn red, it's totally generic and can be on its own. Another way you would use these is for callback systems. Let's say I wanted to know when a process was done, like in coroutines is a great example. I could run a sequence of events, and I want to notify all of these objects to change color when that event ends. I could do the same thing through a callback system. And here, we can actually create that one pretty easily. Let's create a coroutine for, let's say, change cubes. Change cubes routine. And let's say after 5 seconds, right, you would return new wait for seconds. Let's say after 5 seconds, I wanted to notify whoever wanted to listen about, I want to notify basically whoever, or a callback system. I want to be notified when 5 seconds is up. The way we can do that is we can actually embed in here a delegate and event. And that leads us to a newer C# topic, but you can actually convert both of these lines into one by using what's called a static event action. Here we go. Static event action, and this action is going to take a color parameter, and we can basically just call this on update color. This works the exact same way as these two lines. This is just a more modern format for the same thing. We have actions, which allow us to pass in parameters, and then you also have funcs, which allow us to return information, which is definitely a topic for another day. But what's cool here is this works really well for the callback system, because what I can essentially do here, and let me fix this, make sure it's not broken here. I believe we do on update color, instead of calling it like a function, we say invoke, and we pass in the color. So color.randomHSV. And where's my color? Invoke color, yeah, weird. Random dot. Weird. Not sure why that wasn't populating, but there we go. Okay, so yeah, so now this exact same implementation, nothing changed, it still works. What's really cool though with this enumerator here is I can actually pass in an action as a callback. I can say, hey, action on complete. And I can actually execute code when this changes. And the way that's gonna work here is we're gonna execute our code, wait 5 seconds, and then we're gonna listen. We're gonna say, hey, is there something in on complete? And you can actually just set that to null to make it optional. And essentially what we can do is we can check. We can say on complete, is it null? You can use a question mark like this. And if it's not null, meaning that there's actually something in that action, then we can simply invoke it. And if there was a parameter to pass in, we could do that too. But I'll show you how this works just out of the gate. Inside of our update, let's also call that coroutine. So we say start coroutine, change cubes routine. And then inside here, when I open up change cubes routine, there's an optional parameter. And you'll see here it's an action. And using a lambda expression, and this is where we get really advanced, guys. And I know there was a poll that's requested, especially in the email. You guys want more advanced stuff. If you guys want to really master this stuff, you should absolutely book a chat and book a call with me, and we can talk through how to get really good at this. Because if you want to be a paid software engineer, guys, you have to know these advanced topics, and you have to be able to work with them. What's really cool about this is I can say, hey, when did 5 seconds end? I can create an anonymous method right here that basically is just going to do exactly that. I'm going to pass in line debug.log, 5 seconds is over. 5 seconds has passed. And we use these a lot, especially when we communicate with web servers, because I want to know when certain events are happening and when they're completed, and we'll put them in here. Okay, and there. And we got, hold on, missing a bracket. We got 1, that's for the debug.log, and the start coroutine. There we go. And I don't think we need 1 in here for the debug.log because it's inline. Okay, cool. All right, we save this, and if we actually test it out, let's go ahead and run it. We should see that in 5 seconds, a debug message is going to be printed out because that's our callback. Our callback is to notify us that 5 seconds has passed. If we hit space, and then we should see in the message down here, there you go, 5 seconds has passed. So we can use this to create some pretty cool mechanics. For example, every time you destroy an object, after 5 seconds, you can create an event that spawns a new object. And that could be done through a callback system. Anytime you need to get information back or when a sequence is done running. When I was building casino software, we used to create these really intense animations, and it was a chain of coroutines running. And I needed to know when it was done so that I could trigger a win screen, for example. That's exactly how you would use a callback or an action to do just that. Let's see here, guys. So that's going to wrap this up. This was a definitely more intermediate to advanced to follow along with. The important thing here is that if you are on this journey, you're learning how to be a software engineer, game developer, this is what you're going to see on the day-to-day working professionally as a Unity developer. If you are currently building your games using get component all over the place, I promise you that is incorrect, and it will affect you in the hiring process. You want to learn how to write code like real software engineers and how to create maintainable, flexible, scalable systems. Notice everything here doesn't rely on anything else. The cube is independent, the turn red is independent. This cube here, if we wanted to bring it to another script, if our turn red was not in that class, this is the only line of code that needs to change. Everything else is independent and self-containing, executable, which is great. So thanks for coming out. Hopefully you got value in this. I know this was a quick explanation of this stuff. This topic is severely covered in the C# Survival Guide. There's entire dedicated sections to it. If you're a student of the program already, you can go to the C# Survival Guide. We have hours of content on how to use delegates and events, action, and func. If you're not in that program and you want to learn to do this stuff, go ahead and book a call with us.